Hello everyone. So today I'm going to be guiding you through our new Phoretix Toolbox freeform image analysis software. Hello everyone. So today I'm going to be guiding you through our new Phoretix Toolbox image analysis software. Now, unlike our other Phoretix modules of image analysis software, the Toolbox doesn't assume any particular experiment or workflow is being performed. It simply gives you the tools to allow you to perform freeform quantification, measurement, analysis, things like that, and it doesn't try and format the output in any particular way for you. So if you're performing assays with images that maybe lie outside of what our other modules cater for, or even outside of life science, it still gives you a great simple package to quickly and efficiently analyze images. Now, the first step is to bring your image into the software, which is performed within the first tab. We always recommend that you use a TIFF image of at least 16 bits. However, the software is compatible with JPEG, PNG, bitmaps, pretty much any image that you can open in MS Paint, you can open in Phoretix Toolbox. I've just grabbed a demo image here off the internet of some stained cells. And you can see in the top left here we have kind of a 2D view of the image as it's brought into the software. And as ever, we have the 3D view of the image here, and we can enlarge that to view basically a conversion of all of the different pixel values within our image converted into these peaks and troughs. Now, this image here hasn't displayed fantastically. So what I'm going to do is I'm just going to come through to the contrast adjustment and adjust this so I can get the best quality out of the image. So as you can see, by using the auto contrast, the full contrast range here, I can increase the visibility of the image depending on which section of the image I'm looking at. Now, because I've grabbed this image off the internet, it's a JPEG, it's been flattened. This image would have initially been taken in 3 different color channels, but I can use the software to restore the 3 different color channels back to the image, which will make my analysis easier. So to do that, all I do is come across to the channel and move past the section where I can rename it. If I click on the 3 little buttons here, I can change all of the colors, and I can also separate the color channels back out of this image. So if I click on separate color channels, you can see suddenly my image has changed, and I can turn on or off the different color channels. So now we've turned our kind of 1-channel image back into a 3-channel image for my analysis, and you can see that the displays along the top dynamically change as I'm turning on or off channels using the channel selector here. So I've been through kind of so now we've split the channels into their separate colors. I can also change the gamma and the contrast for each channel separately to change how they're displayed on screen. I can also zoom in using the zoom tools here. I can pan along using the pan tool, and I can restore it to full screen by using this button here. Now, this image is actually displaying properly, but if my image had been brought in and needed to be inverted, I can simply use this button here to invert the measurements and invert the image. So the next step within the workflow is the annotations mode. If you don't need annotations, that's fine, but say I wanted to annotate this for presentation, inclusion in a paper, something like that. If I come to the annotate mode and just left click and drag, I can drag out an annotation, and then I can label this as nucleus. I can change the font, I can change the font size of this particular annotation, I can change the text color and the background color, so let's make it blue, just like the nucleus is stained here. And if I just delete this one here, if I left click and drag out another one, I can say this is likely Beethoven. Again, and then this is likely cytoplasm. So I can very quickly add annotations and have control over the format of those annotations within my image. and then I can come along to analyze it. So you've got a number of tools, a number of very common tools for analysis under the Analyze section. So my Select allows me to select any shapes that I've drawn. My Rectangle tool allows me to draw a rectangle, and as you can see, as I draw my rectangle, I start getting measurements from it. Now, because I've got all of my channels selected at once here, the software is taking a measurement from all of the channels at once, and it will tell you which channel it's taking a measurement from. And we've got width and height here, area, volume. These are the measurements from the square that I've just drawn in. And I can change on the right hand side here, I could change the properties of the shape, the color, the line thickness, etc. from where I'm taking my measurements. Using the ellipse tool, again, I can draw a simple ellipse around an area of interest. So say if I had a zoomed in picture of cells, or say if I wanted to measure kind of the nucleus of these cells, I could draw something around it, and then I could get the area and the length, etc. from that circle. I can use the Polygon tool. Now the Polygon tool allows you to kind of freeform draw by left clicking. You can draw a shape of kind of an irregular size. So you can see here as I left click, it's kind of adding the vertices of the shapes. And once I've finished creating my shape, if I click on complete, it's drawn as a shape and then the measurements are taken. And if I want to move this shape, I can use the select tool, and then from there I can adjust any of the vertices that I've added, and reform that shape. We've also got the option to perform background removal on any of the shapes that you've drawn. So you can use an average of the pixel intensity around the edge of the shape. You can use surface minimum, so set the edges as the minimum background removal value. If you use shape minimum or shape maximum, the software will allow you to choose another shape to take the background value from, for background subtraction. And shape mean, again, allows you to define another shape within your analysis. Use the mean value of the intensity of the pixels within that shape, and use that as the background subtraction method. We've also got the ability to very quickly draw a grid. So you can draw out a grid of fixed, of editable size, and place that over any kind of array images that you want to analyze, and then get all of the measurements. Once you've fixed the grid in place, you can get all of the measurements for each of those grids, and then you can use the select tool to change kind of where the squares are in that grid, the size of the shape of the squares, sorry. So if you're using an array that is irregular, you can bend the grid around kind of your array to make sure that you're still getting accurate measurements. It doesn't enforce a kind of extremely horizontal or extremely vertical grid. You can use the auto trace tool, and the auto trace tool will only work on a single channel. And I don't think this is the best image for it, to be honest. But if I just click, so if I just click here, you can see it's auto traced around this section here. So the auto trace tool, the way this works is it will, from where you left click on an object in your image, it will spread out a number of pixels around that left click, which is defined by the trace bounds value. That's how many pixels it will extend beyond. And there is a threshold value which basically tells the software, if I extend my area for selection this many pixels outside of my left click point, the threshold defines how the intensity must change of the pixels before the selection will stop. So if I left click here, the software will read 200 pixels in every direction, and then it will, until it gets to a threshold where the pixel that I left clicked, the threshold is up to 50 intensity value above that. It takes a little bit of getting used to, but it can save a huge amount of time when trying to select objects on an image. You can also draw straight lines and get measurements from them, and if you are using the line, polyline or curve tools, you will also get a profile of the line that you've drawn. So this is especially useful for things like 1D gels, 2D gels, arrays, dot blots, things like that, where you want to see how the profile of a lane or a channel changes over the length of the line. So people that have used our other image analysis software like Phoretix 1D for doing 1D gels and blots will recognize this kind of profile, the lane profile of a line. So the line tool, we just left click and drag, and again we've got all of these kind of properties to change the color and the thickness of the line, anything like that, and the background subtraction, although you can't do background subtraction on a line particularly well. The Polyline tool allows you to do freeform lines. So as you left click, the software will join up the lines from where you left click. So if you want to draw a really irregular, if you want to get the profile of a really irregular line, for example, or a really irregular shape, you can keep doing that, keep left clicking, and then when you're finished, click on complete. The line will be drawn, then can be manipulated, and you can start to see the profile of that line as well. And as you'll see, the profile of this polyline that I've just created is overlaid on top of the profile of the other lines that I've drawn on the image. So if you were doing a 1D or a 2D gel or any kind of like array, dot plot, something like that, you could overlay the profile lines over each other to see how they differed. And then the curve tool allows you to just left click, drag, and form basically a curved version of the Polyline tool with a certain amount of smoothing to allow you to kind of curve around smooth objects. So a particularly good use of this is here in the kind of on the red channel with my presumably cytoplasm, although I didn't perform this experiment. I can very accurately trace the outline of these curved objects here, and then once I've completed, I could then get my measurements for kind of the area of the shape and the length and things like that. So be very useful for tracing irregular shapes, tracing irregular cells, and getting measurements for the area within them and the length of them, the size of them. You can be doing things like wound healing assays. If you've got multiple images over time, you can use the simple kind of curved line to measure the volume of cells on either side of the cut as it closes, things like that. So as you can see, it's a simple tool, but it's very powerful in that it doesn't kind of force you into any singular workflow and can give you very quick results using very easy to use tools without having to install any other kind of prerequisites or anything like that. So once you have finished your analysis, you can then export the results in a PDF or as a CSV for use in Excel by using these two options here. You can export your presentation image, which again gives you an image which is great for presentations, papers, kind of grant submissions, things like that, anywhere where you would typically use an image. And you can also copy all of the measurement values to your clipboard and then paste that wherever you want it to go. MATLAB, Excel, anywhere that kind of supports the pasting of table data. Word would format it into a table. And of course, this is also available in 21 CFR GMP solution. As with all of our software here at TotalLab, it fits into our TotalLab GXP module. So this would allow you to say, if you were working at a startup and you were kind of coming up with novel techniques, novel analysis or image analysis techniques but you wanted to be able to come up with a workflow that is then going to be put into production for a 21 CFR or GMP requiring environment. You can use the toolbox to kind of develop your workflow and then put that into a production environment, rather than using kind of other pieces of software that are in the market that allow you to do kind of simple image measurements but are not 21 CFR compliant. So even if you do come up with a workflow within that piece of software, you then need to move to a different piece of software if you wish to gain regulatory compliance. So that's the Phoretix Toolbox. It's a completely open piece of software, allows you to get basic measurements without any kind of automation or any kind of guidance from the software. As ever, thanks for watching, and if you'd like to try out a free trial of our Phoretix Toolbox software, check out the links in the description below.